Alright, geometric sequences are when you are taking a number and multiplying it to get the next number. So an example of that would be 2, -6, 18, and -48. So how are you getting from 2 to -6? That's right, you're multiplying by -3. How do you get from -6 to 18? You multiply by -3. And same thing here, multiply by -3. If you're ever having trouble seeing that relationship, break it down into an equation. So 2 times what gives you the other number? So in other words, 2 times x, or 2 times what number, gives you the next number, -6. And we could divide by 2, and x would be -3. And you can do that with any one of those consecutive numbers that we have there if you're not seeing that. Sometimes that's better to use if it's a fraction that you're multiplying by. This number, this -3, is known as our common ratio. And it's always going to be a multiple. It's not a division. It's always a multiple. So even if you were getting smaller, like let's do one more example. For instance, if we had 8 and then 4 and then 2 and then 1 ... In this example, it's getting smaller, so don't say it's divided by 2 because we need to do a multiple. What can we multiply 8 by to get 4? Well, if you're having trouble seeing that, again, make an equation out of it. How do you get from 8 to 4? 8 times what gives you 4? So divide by 8, and what does 4/8 reduce to? That's right, it's 1/2. So we're just multiplying by 1/2. Think of it, half of 4 is 2, so times 1/2. Half of 2 is 1, so multiply by 1/2. So 1/2 there would be our common ratio. Now let's look at the next now. How do you get to the next number if you have the current number? And that formula looks like this for next now. It's the next number equals the current number, or our now, times something. Alright, so this last example we just did with the 8, 4, 2, and 1, if we wanted to get to the next number, we would write next equals, and let's start with that first term. So our current number is 8, and then times, what was our common ratio? 1/2. So 8 times 1/2 is 4. That's our next number. Now we could repeat the same process again. So we'd write next equals now times 1/2, or next equals now. What's our now number now? That sounds funny to say. It's 4. So now we're with 4, and we want to get to the next number 2. So 4 times 1/2, and that gives us 2. I don't know about you, but I would get tired of doing that after a while. So this only works if you either A, have patience, or I guess it's just A. If you have patience, you only want to use it with small sequences. Like if we were finding the 50th number, would you feel like doing that 50 times? Probably not. So let's learn the explicit equation for this. So an explicit equation is one where you can find out any term number just by plugging in the term number for n. So we're going to learn 2 different equations for explicit. You guys can use whichever one you're most comfortable with, but you need to be able to use both of them, or apply both of them. So using the first term, we can say a to the n, where n is our term number, equals a, where a is our first term, and then r is our common ratio. Like in that last example, that would be the 1/2. And n, once again, we already said was our term number. We just need to make sure we subtract it by 1. So let's use that last example again. So if we had 8, then 4, then 2, then 1, we said our common ratio is 1/2. So that's my R. My first term is 8. So plugging that in, it would look like this. A to the n, or a times n. It's actually read a of n, where n is the term number. You can also think of that as just being y. It's like our y equals, if that confuses you. And then our first term is 8. Our common ratio is 1/2. And then our n, we don't know. And then minus 1. So if you wanted to find the fifth term, you'd plug in a 5 right there, and you would get 5 minus 1, which is 4. So you would do 8 times 1/2 to the 4th power, and make sure that you do order of operations. So we do those exponents first. So 1/2 times 1/2 times 1/2 times 1/2, and then we would multiply it by 8. And we can probably do that in our head. 1/2 to the 4th power is 1/16, and then 1/16 times 8 is 8 over 16, which is 1/2. Isn't that what our fifth term would be? That's our first term, second term, third term, fourth term, fifth term. If you just multiply it by a half, it would be 1/2. So yeah, that formula works. Now let's look at using the Y-intercept. So that's the way that your book uses, is on the left, using the first term. You also need to know it using the Y-intercept. And we're going to use a table to come up with that. And this looks very similar. We can use the same letters so we're not confused. It's a of n equals a times r to the n power. But a is not going to represent the first term. It's my Y-intercept. So that's my 0 term, or you can just say the Y-intercept. And r is still my common ratio. And n is still going to be my term number. So not much has changed there. All right, let's look at that other example and set it up that way. So 8, 4, 2, and 1. Remember, we can make a table out of this. So that's really my first term, second term in the sequence, third, and fourth. And we need, for the Y-intercept, we need the 0 term. So if we go back here, remember we're multiplying by 1/2. What's the inverse of multiplying by 1/2? You could say dividing by 1/2, or that's the same thing as multiplying by the reciprocal. So if we just flip these, we're really just multiplying by 2. So 8 times 2 gives us 16. Or you could have just repeated that pattern backwards. 2 to get to 4, we double it. 4 to get to 8, we double it. And then double 8, we get 16. Okay? So we're going to use that 16 for our a value. So let's plug it in. And that would look like this. A of n equals 16 times 1/2 to the n power. And let's say if we plugged in a 5 there. If we wanted to find the fifth term, we could plug in a 5. So if we did 1/2 to the 5th power would be 1 over 32. And then 16 times 1 over 32 would still give us 1/2. So that's the same thing we got over here. We got 1/2 for the 5th term. We'd get 1/2 for the 5th term. So really the two methods are really similar. It's just the second method uses the Y-intercept. The first method, you just have to use the first term, but you have to remember to subtract 1. Okay? All right, let's do one quick reminder on arithmetic sequences. I want you to be able to differentiate between geometric and arithmetic. So arithmetic adds to get to the next number. And geometric, we just learned, multiplies to get to the next number. So that's the key difference between arithmetic and geometric sequences. So which sequence would this one be? If you had 8, 6, 4, 2. Or what are you doing to get to the next term? That's right, you're subtracting 2. So since we're subtracting 2, that would fall under arithmetic because we're adding a negative 2. Alright, let's try one more. How are we getting from 1/2 to 1/8? Well, I know that I can always set up an equation here if I'm unsure. So 1/2, let's see if geometric works. If we multiply, so 1/2 x equals 1/8. So if I multiply by the reciprocal 2 over 1, x would give me 2/8, which is 1/4. So if I multiply the next one by 1/4, 1/8 times 1/4, that gives me 1 over 32. If I multiply the 1 over 32 by 1/4, it gives me 1 over 128. So this one's definitely going to be geometric, and our common ratio is 1/4. Alright, I think you're ready to try some on your own. Alright, you're up. Just kidding.